SQL is the most important programming language when it comes to preparing for data science, data analyst, or data engineering interviews. Understanding SQL is crucial if you want to query your database, if you want to clean or transform your raw data, if you want to create reports, if you want to create dashboards, and basically if you want to manage any data that is sitting in your database. In this video, we will be talking about the most important SQL concepts when it comes to preparing for data interviews. By the end of this video, you will have a base understanding of all the important concepts along with understanding how to use relevant SQL syntax for each. I'll be covering topics in basic SQL, commands in SQL, data types, built-in functions, order of execution, CDs, window functions, subqueries, and everything in between. Stick around till the end if you want to get an overall understanding of how SQL works. It's going to be a lot of information in one place, so feel free to come back to this video and replay concepts whenever you are practicing. With that said, let's jump into the video. Hello there, if you're new here, I'm Sanjana. I'm a software data engineer currently based out of New York, and I create content on data engineering, AI, and everything in between. So if you're looking to break into data or simply upskill, then follow me along this journey and make sure you're subscribing to my channel. Now, let's get into the video. First, what is a relational database and why do we need SQL? A relational database organizes data into structured tables where each table consists of rows and columns. Each row represents a record and each column represents an attribute for that record. SQL enables users to interact with the database, allowing for data retrieval, updates, and management in a structured manner. Now, what are SQL commands? Commands are used to perform operations on your SQL tables. SQL commands enable the user to interact with the database. Now, there are different types of SQL commands, and they can be categorized into 5 types based on their functionality. First, let's look at data definition language, which is DDL. The DDL commands are used to define and manage database structures. The most common DDL commands are the create command. The create command creates a new table. Here, we are creating an employees table with different columns, namely employee ID, first name, last name, etc. The alter command modifies the structure of an existing database. In this case, we're adding a column called phone number. The drop command deletes a table. It deletes the entire table without even preserving the structure. Whereas the truncate command removes all the rows from a table without removing the table itself. The difference between the drop and the truncate is that drop completely removes the structure, whereas truncate only removes the data and preserves the structure of the table. The rename command renames a table or a column, and the comment command adds comments to the tables or columns. That was about the data definition language. Let's move on to data manipulation language, which is DML. These commands are used to manipulate the data within the database, and the most common DML commands are insert, update, delete, and merge commands. The insert command inserts records into the table. In this case, the values are specified for entry into the employees table. We say insert into name of the table and column names, then we say values and insert the data into the table. The syntax for this is update employees, then we set the salary and use a where condition if needed. The delete command is used to delete a specific row from a table, as opposed to the truncate and drop commands, which completely remove the table. The way it is used is by writing delete from table name and use the where clause specify the condition. And finally, we have the merge command, which is used for upsert operations. Upsert is short for update and insert. And the way we use it is merge into table 1 using table 2 on the common column name. When matched, then we place the condition, and when not matched, we also place the condition over there. In this case, the query updates the salary when the employee ID matches, and if the employee ID is not present in the table, then a new record is added using the insert command. That was about DML, which is data manipulation language. Now, moving on to DCL, which is short for data control language. These commands are used to control access in the data. The most common DCL commands are grant, revoke, And deny grants users permissions to write or perform specific operations on a database or a table. The revoke command revokes access on a certain table, and the deny command denies specific permissions to the user. That was about DCL. Now, moving on to TCL, which is Transaction Control Language. These are commands that are used to manage transactions. And the most common TCL commands are commit, rollback, save point, rollback to save point, and set transaction. Commit saves all changes made during a particular transaction. Rollback undoes changes made during the transaction. Save point sets a save point location within a transaction. Rolls back to a specific save point, and set transaction sets properties of a current transaction. That was about transaction control language and most common commands. Now, data query language, also known as DQL. These commands are primarily used for querying data. And the most common commands here are the select command, which queries the data from the table, the distinct command, which returns unique values, the order by command, which sorts the result set by one or more columns, the group by command, which groups rows sharing a property and applies an aggregate function, and the having command, which filters groups based on a condition. And of course, this is applied after aggregating the data. And you can understand how you can use them in your queries. Let's move on to data types in SQL. Data types specify the kind of data that can be stored in a database column. This can include strings, integers, boolean, float, date, identity, you name it. Here's an example products table where columns are specified using various data types. This includes int, varchar, decimal, float, boolean, and timestamp. Moving on to constraints. Are rules applied to specific columns in a table to enforce data integrity. And some of the most common constraints that you will encounter are primary key. This ensures unique identification of each record. A function to note in this example here is identity, and we'll come back to that in built-in functions, but I just wanted to touch upon it while we're here already. So, if there are no unique values, then identity is used to define unique values. In this case, it auto-increments an int field starting with 1, and it incrementally adds 1 for every new record that is added. That was about identity. Now, coming back to constraints, the second most common constraint you will encounter is foreign key, and this is created to link two tables based on primary key. Here's an example of how you can use foreign key. Then we have check, which validates the values meets specific conditions or not. We also have not null, which ensures a column cannot have null values. Then there is unique, which guarantees all values in a column are distinct. And finally, there is a default constraint, which sets a default value for a column if nothing is specified. You can find examples of how to use them on the screen. Now let's talk about SQL clauses. SQL clauses are the building blocks of a SQL query, and they help us define what data we want to pull from a database and how it should be filtered, grouped, and presented. The most common SQL clauses that we will encounter almost every day: select, from, join, where, group by, having, order by, limit, and offset. It can be seen from the example on the screen. While this is how you write a SQL query, the order of execution is, however, different. The order of execution, however, starts from the from clause, where the from clause identifies the table or dataset that we're querying from. Then it joins it with the departments table, in this case, on a common column. Then the where clause is applied to filter data according to the condition. Then the data is grouped, and to this group data, the select clause is applied where the department name and the count of the employees are derived. Oh, sorry, before that, after the data is grouped, the having clause acts as another where condition, but now on the filtered data. And on top of all of this filtered data, the select clause is applied to select the department name and the count of the number of employees. Once these two are selected, the data is then ordered in descending order based on the count of the number of employees within each department. And this is limited to 10 records by offsetting the first record. Offset over here skips the specified number of rows. With that said, I hope you have understood how to write a simple SQL query and what the order of execution of that query would be. Now, let's talk about operators. Operators in SQL allow you to perform operations on your data, whether it is mathematical, logical, or combining multiple query results. There are different types of operators. The first being arithmetic operators. As shown on the screen, arithmetic operators are basically addition, subtraction, multiplication, division, and modulus, which is nothing but the remainder. Example syntax is shown here. All the operators are mostly used in the select clause. Then we also have logical operators, which are used for making logical comparisons. The most common logical operators are AND, OR, and NOT operators. As shown on the screen, these are mostly used in the where clause. Comparison operators are used to filter data based on certain conditions. The most common comparison operators are equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, between, in, and like. The between operator selects values in between two values. The in operator matches any values in the list, and the like operator searches for a pattern. And finally, we have the union and union all operators. Union combines two result sets and removes any duplicates there are, whereas union all preserves the duplicates. That was about SQL operators. Moving on to built-in functions in SQL. Built-in functions allow us to perform predefined operations on SQL tables. The most common functions are aggregate functions, which perform a set of operations to return a single value. Examples of aggregate functions are count, sum, average, minimum, and maximum. The way you use it is you say select, you write the aggregate function, and then use the from clause. Then we also have string functions, which operate on string values and retrieve string data. We have length, which returns the length of the value. We have upper, which converts it into uppercase, lower, which converts it into lowercase, substring, which derives certain number of characters from that string, trim, which removes white spaces from the string, and position, which returns the position of the first A names as shown in the syntax. Then we also have date functions, which include current date, current time, current timestamp, date add, which adds certain month in this case to the date, date difference, which calculates the difference in dates, which extracts the specified part from the date. Then we have math function, which rounds value based on decimal spaces. We have absolute value, ceil, which rounds it to the nearest integer on top on the higher side, and floor, which rounds it to the nearest integer on the lower side, and power, which calculates the power. Then we have conversion functions, which are cast and convert. Cast function temporarily casts a certain value on a column and converts it to a different data type, and convert permanently converts a certain column to a different data type. Then we have conditional functions, which are case. The way you use it is select case when and write your condition. Then you write the value when this condition is satisfied. Then you place the else condition and the value for that particular else condition, and you end with the column name. In this case, it returns the high or low salary based on the salary. Then we have coalesce, which returns the first non-null value. And we also have null if, which returns null if the value is 0. This is all example usage for each of these functions. Now let's talk about the most important SQL clause, joins. When I think of joins, I like to imagine Venn diagrams. On the screen, you see a variety of Venn diagrams. Before you freak out, what you need to know about joins is that they are pretty simple. They can be categorized into two types, inner join and outer join. Inner join, as you can see on the screen, is nothing but the intersection of A and B. And the way you write this in SQL is by simply adding the tag inner in the join clause. Outer joins, on the other hand, again be classified into two types, full outer joins and exclusive outer joins. Full outer joins include left join, right join, and full outer join. Full outer join is nothing but A union B. Left join is nothing but A including A intersection B. And right join is nothing but B including A intersection B. Left join excludes the part of B which is not in common with A, and right join excludes A which is not in common with B. Here A and B are nothing but tables in SQL. Exclusive outer joins can also again be classified into three types: exclusive A, exclusive B, and exclusive of A intersection B. In Venn diagram terms, exclusive left join is nothing but not B, and exclusive right join is nothing but not A, and exclusive full outer join is nothing but not A intersection B. It's as simple as that. Now, apart from inner joins and outer joins, we also have cross joins, natural joins, and self joins in SQL. Cross join is the Cartesian product of two tables, and it is used to get all possible combinations of A with B. Natural join is used when you automatically join two tables without having to define the common names. And self join is used when the same table is joined with itself based on underlying relationships. Moving on to subqueries in SQL. A subquery in SQL is a query nested within another SQL query. It is used to perform operations that require the result of one query to be used as the input for another. Now, there are several types of subqueries. Let's go over them one by one. First up is the single row subquery. A single row subquery, as the name suggests, returns one value. Here's an example of a single row subquery. As we can see, the subquery returns the average salary of employees, which would just be one value. And this is fed as input to the outer query. Then we have multiple rows subquery. As the name suggests, it returns multiple values. Here, assuming there are multiple departments, in the departments table, the ID for each is returned to the outer query. Then we have a correlated subquery. A correlated subquery depends on the outer query, where each row is compared with the outer query. In this example, we see that the salary is being compared with the average salary of the subquery. Then we have nested subqueries, which are useful for complex filtering. Here we see there is one subquery inside another subquery. Then we have inline view, which returns a temporary view, and it is mostly used in the from clause. And finally, we have the scalar subquery, which returns exactly one value, one row and one column, and it can be used anywhere. Now let's talk about window functions in SQL. Window functions let you do calculations on SQL rows while preserving the row itself. Unlike aggregate functions, they help you analyze the data without actually grouping everything into a single result. To rank and order SQL rows, access data from previous and next rows, divide data into buckets or segments, calculate running totals, moving averages, cumulative distributions, and retrieving values from a particular position within the result. Now let me show you the example syntax for window functions and the different types of window functions with the help of an example. This is the base syntax for window functions. So what we do over here is first write the window function, then we place over, use partition by, write the column names, order by, write order by column names, and use a frame clause if it is applicable. This is an example SQL query which contains several window functions that we just spoke of. Rank, dense rank, and row number. First, let's talk about rank and dense rank. Ranks rows in a specific order have the same rank, then it skips the next number. So let's say two people came first in the department, then the rank function gives the position 1 to 2 people, skips 2 and moves on to 3. Whereas dense rank preserves 2 as well. Row number is pretty direct. It gives the row number of that particular row. Lead and lag are used for accessing data from previous or next rows. First value, last value, and nth value are used for retrieving the data from a particular position. Cumulative distribution and percent rank are used for calculating running totals, moving averages, etc. So this is example usage of window functions. Now let's talk about CTEs. CTE, or Common Table Expression, is a temporary result set that you can reference within a select, insert, update, or a delete statement. So the reason you use CTEs is to improve code readability and make complex SQL queries easier to manage. The basic syntax of writing CTE is as shown on the screen. So first, we write with give CTE a name and write a SQL query. Then we use this expression Then we use the CTE in another query to retrieve results. This is the base syntax of CTEs. Here's an example of how you can use CTEs. Here, we use customer sales as a temporary result when we query customer ID and the total amount of the customer. Then we use the CTE to retrieve the total sales that are greater than 1000. As we can see, this example divides the query into two parts, the CTE expression and the main query. So those were some basic and intermediate SQL concepts that are important for data interviews. If you watched until here, then definitely kudos to you. Go ahead and practice all of these concepts as much as you can. Remember, practice makes perfect. So practice, practice, and practice. I'm curating a document more like a cheat sheet to help you remember all of these concepts. I'll put the link in the description, so definitely check it out. Again, thanks for watching. Make sure you like, share, and subscribe, and I'll see you in the next one. Bye.